idea. Okay. Okay, so here we go. This is a Math 112 trigonometry class, and I spent a few minutes before we started recording giving you some introduction to the course and the class times, and the fact that we'll be using Math XL for doing the grading and so forth in the course. What we're going to talk about today is we'll go ahead and get started, and for those who might be watching the DVDs or video segments, is this session today is going to be on angles and their measure, and we're going to break it up into two segments. The first segment is going to be addressing how we measure angles, and we have two predominant ways that we use in science and application areas for measuring angles. One is degree measure that most of you are familiar with, and another one that might be new to many of you is a very powerful way of measuring angles called radian measure. That'll be the first segment, and that'll take a little while. It's part of, in this book we're using, section 6.1. Also in that same section of the book, we're also then going to have a second segment today on sector area. In other words, if you take a circle, and you cut it into a sector, like a slice of cake, then how much area is in there? It could be an agricultural field where you've seen circular sprinkler patterns before, where they have big circular sprinkler patterns. Well, you might be interested in how much water you need to lay down on a certain size sector of that circle. How much water, if you want to get an inch of water on there, how many gallons of water is it going to take as a farmer to water that field or apply fertilizers or things like that? Okay? So there's a lot of real practical application to this stuff. So it's not just the pure math like we're going to be focusing on today, but that's just one simple example of a practical application of this sector area. And then we're also going to talk about what happens when we have something that's spinning or moving in circular motion. And so we'll get to that later today as well. Okay? So let's begin with how we measure angles. Okay? Now we're all familiar with our traditional X, Y axis system for drawing relationships. This we oftentimes call our input. You're going to hear a lot of review here. And we then plot that, and that's oftentimes the family of all of the possible inputs in a function is called the what? All the possible inputs, if you're thinking of a function. Here's your x coming in. You process it as a function. You get some output, right? So here's your input. Here's your output. We oftentimes call the x the input, the y the output, and then the family of all the possible inputs is called the inputs, called the domain. I knew I'd better review that, okay, with many of you. And then the family of all the possible outputs that show up as the y values on your graph are called the family of all of that stuff is called the range. And as I mentioned in college algebra, is notice these are in alphabetical order. X, Y, I, O, D, R. Okay? Don't forget that, like some of you did. Okay? So, anyway, we're familiar with this XY Cartesian coordinate plane. Then, what we do here in trigonometry is we talk about rotation. We talk about rotations occurring. So if we measure our positive rotation counterclockwise from the x-axis and kind of use that as a standard, this term, let's use that as a standard, then that'll be positive angle measure. Positive angle measure, counterclockwise from the x-axis. Now, what is an angle? An angle, and the book describes, any trigonometry book will describe this, is we have something called a ray. An array is a straight line starting from some point and pointing in a certain direction. If we rotate that ray to some other location, then this is the initial side, and this is the terminal side. A measure of the rotation that has occurred is called an angle. A measure of the rotation that has occurred is called an angle. We use a lot of the Greek letters to represent angles in most textbooks. So here's a few of the Greek letters that we will be using throughout the course. This symbol is theta in the Greek alphabet. If I drew something looking like a fish swimming to the left, that's called alpha. If I make the letter looking like a bee with a tail on it here, that's called beta. And if I make something looking like a fish swimming straight downward, usually a little taller and skinnier like this, that's called gamma. Those are the ones that we use most commonly to measure angles in trigonometry. Okay? Try to commit these to memory. Actually, you're going to hear me say them, and we'll be writing them down every day, so it'll become familiar to you, just like your phone number. Okay, so you got the idea? Now, if we let the initial side start here on the x-axis, and we rotate all the way around, we have then a complete rotation, one revolution. So let me draw that. Here's one revolution, right? If you see me misspell something, please catch me. Okay, because like I said, I don't want any mistakes on these recordings. Okay. So we have one revolution. That is equivalent to something called degree measure. And we all know that one complete revolution is equivalent to how many degrees? 360 degrees. Okay, so one revolution is equivalent to 360 degrees of rotation. There's a radian measure also, another way of measuring angles, called radians. And so let me take a second to talk to you about radian measures so I can kind of mix this stuff at the same time, mix it all together, and totally confuse you. Okay. So, if I took a circle, and we started the college algebra class, I believe, talking about circles, okay? So if I took a circle, then we know that a circle is a family called a locus, a collection, locus in math terminology, a collection of all points equidistant from a fixed point. The collection of all points equidistant from a fixed point. Then that means that this is the fixed distance, and then all the points that are equidistant from this, what we call the center, form this shape called a circle. That's easy. We all know that. No matter what size circle I draw, it's going to have that characteristic. Now, if I take that radius like a piece of spaghetti that's been cooked, and I bend that radius on this arc right here, isn't it going to go about that far? Doesn't that look about right? If I took that wet noodle and stretched it on the arc of the circle, right? That amount of rotation from the initial side to the terminal side is called 1 radian. That central angle there is called 1 radian. One radian. Can you remember that? You bend the wet noodle on the circular arc, equal in length to the radius, and the angle that's formed, the rotation from this initial side to the terminal side, is called 1 radian. Any questions so far? I hope not. Okay, it's pretty straightforward so far. Now, you could imagine back several thousand years ago, sitting there with a piece of sandstone, or maybe even just smooth sand, and you could draw with a piece of cord or something a pretty accurate circle, couldn't you? And you could imagine taking then that chord and bending it on the arc and seeing how many of those radiuses you had to go all the way around. So you can imagine doing that several thousand years ago, right? So it looks like one radius is about that much of rotation, right? And then let's see if I can accurately kind of do another one. Here's another one, right? And if I do another one, it's going to come down about here. And notice, it doesn't look like it's quite halfway around. Darn. It would have been really nice if it would be exactly halfway around, but it's not. So let's keep on going. Let's put another radius on there. Let's see, here's one. Okay, so we got 1 radian. Here's now another radian of rotation. Another radian gets me to here, right? 1, 2, 3 radians now. Keep on going down to about here. And then let's put another one in down here. And then another one here. And my drawing, obviously, on this whiteboard is not accurate. But what's going to happen is we're going to come up short. We are going to come up short here of where that last radian lies. So the Greeks, this was a big problem back then, is they needed to come up with a way to accurately measure the complete distance around there. And so what they did is they said there are 2 pi. They used their another letter from their alphabet that you're familiar with, pi. There are 2 pi radiuses to get all the way around. And you all have seen this before. This is the formula that you're familiar with from even beginning algebra level for the circumference of a circle. So if you look at what that number is, pi is an irrational number, 3.14159, keeps on going, never terminating, never repeating itself as a decimal, and that's the approximate value shown right there of pi. So if you look at that value, it's a little bigger than 3. So look at what this is. 2 times that number, a little bigger than 3, is a little more than 6, isn't it? Radiuses. Everybody see that? 2 pi, mentally thinking about it. A number a little bigger than 3 times 2 is going to be a number a little bigger than 6 radiuses to get exactly around 1 revolution. So there are 2 pi radians. 2 pi radians is equivalent to 360 degrees of rotation. Okay, a new way of measuring angles for you. Any questions? Pretty straightforward so far. Okay, so now I gave you a handout. If I draw a circle, then here is 0 degrees. When you get all the way around, that's going to be around to 360 degrees for 1 complete revolution. Everybody feel okay? So what I'm doing is there's a couple different handouts. I think the one that shows a grid is the first one that would be appropriate. And let's see if I can get this to show up on the back in the control room. Is this large enough to be visible? Or should I make it a little larger? That's questionable. Okay, so what I'm going to do is I'm just going to put this image in the center here, and I'm going to enlarge this a little more. See if we can get that to be visible on a recording. How about that, Dean? Is that going to work on a recording? So. Okay. So if you're watching a recording, this might be visible to you. Okay. Now, let's come back up here to the board. What we want to be able to do is we want to mainly be able to come up with 16 different angles and have in our brain what the degree and radian measure of those angles are. 16 important angles, and we want to commit those to memory. It's not hard. All you have to do is think of this as something you could eat, like a cookie or a cake or a pie or something, okay? And we're just going to cut it up into sectors. So here we go. We know that 0 degrees is equivalent to 0 radians. We know that 360 degrees is equivalent to how many radians? Cover up the board. 2 pi, right? 2 pi radians for rotation, right? Those are, that 2 pi radians and 360 degrees are equivalent to 1 revolution. Pretty obvious. If you cut that into half and measure positive angles, then here we go. We're sweeping. Here's our initial side. Here's our terminal side, my marker. We're sweeping around here. If we go halfway around, we know that we've cut these ending values in half. So this is 180 degrees, and that's equivalent to pi radians. Pi radians. If we cut, here's where we're going to practice fractions a little bit, okay? If we now cut these in half, our terminal side is going to be straight up. And that rotation we've gone through is half of 180, which is 90 degrees, or pi over 2 radians, a half of a radian, a half a pi. Okay. Think about that number, pi over 2. A number a little bigger than 3 divided by 2 is a number a little bigger than 1.5, right? Okay, now pi is about 3.14. Mentally, take half of that. 1.5 and a half of 14 hundredths is 0.7, so 1.57. I'd like you to try to have that in your brain. Pi you've probably already got in your brain, but try to get pi over 2 being 1.57 into your head, or think about it if you ever need it. Try to remember it. Everybody okay? Feeling good? Okay. Oh, by the way, don't miss trig class. There's a lot of new things for most of you coming at you in this course, and so hearing this is going to be really useful. It's harder to read this stuff out of a book and learn it that way than it is to sort of hear the verbal and the visual interpretation here. Okay, let's take this now. Let's take this 180 degrees and pi radians, and let's cut it into, how about quarters? So actually what we could do is we could come up here to 90 degrees and we could cut that in half. So if you cut 90 degrees in half, we're going to end up, our terminal side is going to be right through there, isn't it? Right here, terminal side. Half of 90 is 45 degrees, and a half of pi over 2 is pi over 4. Okay, so 45 degrees is equivalent to pi over 4 radians. That's a little bigger than 3/4, isn't it? Everybody see that? A little bigger than 3/4 in value? Okay. Now, let's start adding pi over 4 segments together. Here's 1 pi over 4. 2 pi over 4 gets us to here, which reduces that to pi over 2. 2 pi over 4. 3 pi over 4 is going to terminally be right here. 4 pi over 4. With me? 5 pi over 4. 6 pi over 4 reduces to 3 pi over 2. Another way of thinking of that is look at this. It's 3 times pi over 2. Watch. Pi over 2 is here, right? 1 pi over 2, 2 pi over 2, 3 pi over 2. Got it? Equivalent to 270 degrees. And while I'm at it, let's back up here for a second. 45, 145, 2 45s, 3 45s, 135 degrees. 4 45s, 180. Add 45 to 180. Add 45, arithmetic, okay? Add 45 to 180 in your head. 225 degrees. Notice this little symbol, that little superscript. That's a degree symbol. If you don't put the degree symbol, and I'm looking at your work, if you don't have that degree symbol there, I'm going to interpret that as radians. That's not right. So get in the habit, if you're writing degree measure down, always put that little superscript down, indicating that it's degree measure you're talking about. Very, very important. Not just to make me feel good, but to be able to convey the correct information if you're in some other course with somebody else. Okay? So let's see, where were we? Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Ah, here we are, 7 pi over 4. 8 pi over 4 reduces back to 2 pi. And we could keep on going, couldn't we? 9 pi over 4, 10 pi over 4, 11 pi over 4, blah, blah, blah. Okay. If we added 45 to 270, we get to 315. If we subtracted 45 from 360, we get to 315. Doesn't matter which way you go on it. Remember, all we're doing here is in multiples of 45 degrees or pi over 4. Fractional parts of pi over 4. Anybody asleep yet? Everybody's still awake. That's good. Okay. How many angles have we talked about? I said I wanted you to memorize 16 of these things. How many do we have sitting here so far?
8.
We only have 8. Ah, we need 8 more to get into our brain. So, let's take 180 and divide it by 6. 180 degrees divided by 6 is, 6 goes into 18 3 times, leaving a 0, 30. Ah, now 30 degrees is going to be close to 45 here. It's going to be about here. So instead of putting all these dotted lines indicating the terminal side, I'm just going to put a little tick mark on the edge of the circle to indicate 30 degrees. How many radians is that 30 degrees equivalent to? Here's 180 degrees equivalent to pi. What did we do to the 180? We took a sixth of it. So if you take a sixth of pi, you get pi over 6. Pi over 6. So there's one of them. One of those other 8 that we need. Yes, sir?
I'm just kind of curious where the 6 came from.
Arbitrary. It was just me saying, let's cut 180 into 6th.
Okay.
Yeah, that's all. These numbers that I'm getting, though, these fractional parts of a rotation that I'm talking about, they're going to be really useful to us because it's going to lead to something else we're going to memorize. This depends on these. And so it wasn't just totally arbitrary. There was a reason for doing that. Okay. Later in the next session or two, that'll become real clear. Okay, good question. Okay, so let's start adding now pi over 6's together. There's 1 pi over 6. 2 pi over 6 reduces to what? Think of the fraction. 2/6. 2/6 is a third, isn't it? So a third of pi is going to be another pi over 6 added to pi over 6. So here's pi over 3. And just because of the confusion on the board here, I'm going to just write it inside there. Pi over 3 ends up there, doesn't it? So we got 30 degrees. We're up to 60 degrees here, right? Which is equivalent to pi over 3 radians. Feel good? So let's keep doing that as we work our way around. And notice that I've added 2 more angles to that first quadrant of angles. The first quadrant of angles, I got 2 more angles in there. So let's keep on going. So 1 pi over 6. Here we go. 2 pi over 6 reduces to pi over 3 radians. 3 pi over 6. Think about that. 3 pi over 6, pi over 2, right? 4 pi over 6 reduces to 2 pi over 3. 4 pi over 6 reduces to 2 pi over 3. Equivalent to how many degrees? Less than 135. Yeah, look back here, folks. See 30 degrees to 45 degrees, a 15-degree spread there on either side of 45. That's what's going to happen over here. 15 degrees less than 135 is 120. When you get used to this, it's going to be automatic to you. And you're going to see me up here with a stick in another couple days, and I'm going to be holding the stick in the air at a certain angle, and I'm going to have you pop out to me what the radian measure is, one of these 16 angles. And if I hold the stick at 7 pi over 6, actually let me make it 3 pi over 4, since I've already covered that. 3 pi over 4, I'm going to be holding the stick up over here. And you're going to tell me 3 pi over 4. 5 pi over 4. Right? Here's my initial side over here, this arm. There's my terminal side, 5 pi over 4, rotation. Okay. You'll get good at it. And if you aren't good at it, all you have to do is take either one of these, the 30 or 45 degree one, and just start counting. Just start adding them up, and you'll get the fractional parts like I'm showing you here. It's not too tough, but it's very important that you get good at it. Okay, let's keep going. If I add 30 degrees to 120, I'm going to be at 150, which is going to be right in here. And that's going to be equivalent to, let's see, how many pi over 3s or pi over 6s did I have? 1, 2, 3, 4, 5. 5 pi over 6, 6 pi over 6. Look at this, 6 pi over 6 reduces to pi. 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 8 pi over 6. The common 2 reduces to 4 pi over 3. 9 pi over 6. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6. Oh, look at this, is interesting. Look at this. 4 pi over 6. If I add another pi over 3 to that, I get 5 pi over 3. Or you can think of it as 10 pi over 6 and reduce it. And then finally, over here, 11 pi over 6 doesn't reduce. What a mess. But there are only 16 angles there, shown in both degree measure and radian measure. And let's back up now in degree measure from 360 back to 30 off of that is 330. Back 30 off of that to 300. 30 off of that to 270. 30 back off of that to 240. 30 off of that to 210 degrees, and that completes the family. And I gave you a handout that shows you a bunch of that stuff. Okay, back to the computer screen, or the overhead here, is we have this image, and you can observe multiples of pi over 3, right? Actually, let's look right here first. Multiples of pi over 2. 1, 2, 3, 4 of them. Look at multiples of pi over 3. 1 of them, 2 of them, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Look at the 45 degree multiples. At pi over 4, 1 of them. If you go back here to pi and back off 1, you're back to 3/4 of them. If you go 1 beyond pi, you're at 5/4 of them. And if you back off from 2 pi, back off of pi over 4, you're at 7 pi over 4. And then similarly, look here, here's your pi over 6 multiple. Here's 1 pi over 6. If you take 2 pi, which is 12 pi over 6 down here in the corner, 12 pi over 6, and I back off 1, I'm at 11 pi over 6. If I'm over here at 180 degrees, equivalent to pi radians, that's 6 pi over 6. Add 1 to that, and you get to 7 pi over 6. Or back off 1, and you're at 5 pi over 6. So this will help you in the memorizing those fractional parts that I just went over with you. Degrees and radian measure, and then we also could be talking about portions of a revolution, couldn't we? How much of a revolution is 60 degrees up here?
1.05.
A portion of a revolution? It's not bigger than a revolution.
It's 1/6 of a revolution.
Yeah, just look at, imagine this is a cake and you're cutting it up into 6 pieces, right? You're talking about 1/6 of a revolution, aren't you, here? This is 1/3 of a revolution to here. Half a revolution, right? That's, right, 3/6. 4/6 of a revolution is 2/3 of a revolution. And then here is 5/6 of a revolution and a whole revolution. Similarly, you can talk about this being 1/8 of a revolution for pi over 4. And 1/12 of a revolution for 30 degrees for pi over 6. Any questions on that material? One final comment before we end this segment is on your calculator, if you go to mode on your calculator screen, if you have an 83 or an 84 type of calculator, 83 or 84 type of calculator, you need to be very careful here in trigonometry with which mode your calculator is in for radian or degree measure when you do a calculation. Okay, so just be aware of that, that on your mode screen, you typically are going to always want to check this to tell if you're in the correct mode for when you start doing calculations with angles. Okay? Very, very important. Okay, I think that'll end the first segment. And any questions, first of all, before we end this segment? Just got to learn some fractions, folks. Okay, that ends the first segment. And then it's going to take these guys about a minute to queue up for the second segment. And then we'll move on to that material.